Over 4,000 years ago, an advanced urban society built sprawling, geometrically planned cities out of baked mud bricks across South Asia. They left behind thousands of inscriptions, but without a surviving speaker or a readable record, the history of the Indus Valley remains silent. Traditional human philology has reached a standstill. Decipherment usually requires specific comparative anchors that allow linguists to bridge the gap between the unknown and the known, anchors that, in this case, do not exist. The Rosetta Stone provided a way to cross-reference unknown signs with known ancient Greek. Without a bilingual text like this to serve as a baseline, there is no way to verify if a proposed translation is actually correct. Researchers also lack a descendant language. While the wedges of Mesopotamian cuneiform can be traced into later known tongues, the Harappan script has no clear successor to reconstruct its sounds. The final hurdle is the data itself. Most surviving inscriptions are remarkably brief, often just 5 or 6 symbols long. This provides too little context for human intuition to find a pattern. Modern researchers are now approaching these symbols as high-dimensional mathematical coordinates. By using artificial intelligence, we can analyze the script's underlying structure through the lens of probability rather than phonetics. We have reached a point where understanding the Indus Valley requires us to compute their code. Machine learning models begin the process by stripping away the search for meaning. The algorithm treats each symbol strictly as a data point within a larger sequence. The AI generates embeddings. It tracks how often symbols appear and which consistently appear together, mapping these relationships into a 3-dimensional geometric space. This measures conditional entropy, calculating the mathematical probability that if symbol A appears, symbol B follows it in a specific position. These curves plot different levels of structural predictability. Natural human languages fall into a specific middle ground, more structured than random noise, but far more flexible than the rigid, repetitive patterns of computer code. An algorithm can identify the fundamental rules governing a sequence without ever needing to know what an individual symbol represents. This computational toolkit has been applied to the entire Harappan corpus, including the structured inscriptions found on copper plates. The analysis confirms that the script is highly structured and non-random. The sequential arrangement of the signs follows a distinct syntax, which effectively rules out the idea that these marks are just decorative or mnemonic scratches. AI clustering has also identified specific motifs, like dual circles and tree symbols, that behave as stable units across different texts. This suggests the script functions logographically, with symbols representing specific concepts or objects. However, the most significant discovery is the presence of rigid positional constraints. Statistical analysis shows certain classes of signs are exclusive to specific zones. Some symbols only appear at the beginning of an inscription, while others are locked into the final position. Spoken language is inherently flexible. We can reorder words to change emphasis. The Indus script lacks this fluidity. It behaves more like a standardized ledger or a commercial spreadsheet, where quantity must always precede commodity. These extreme structural limits suggest that the script encodes a specialized administrative or ritualistic code, rather than a full range of spoken phonetic language. There is a significant caveat to these findings. Modern neural networks require vast amounts of data to produce reliable results. The Harappan corpus is small, consisting of only a few thousand brief inscriptions. Cautious tone. When algorithms are forced to find patterns in such a limited dataset, they risk hallucinating results, identifying statistical coincidences as meaningful linguistic laws. AI serves as a tool to quantify structural logic, rather than a machine to instantly translate ancient texts into English. This shift has permanently moved the study of ancient scripts toward combinatorial optimization. We are moving away from individual human breakthroughs and toward the measurable verification of patterns. While the exact sounds of the Indus Valley may remain lost, artificial intelligence has provided the blueprint for reading their underlying architectural and social patterns.